Hi friends, welcome back to our Model Maths Nagaraju YouTube channel. First of all, please subscribe our channel if you are newly watching and click the bell button and also click like button, share with your friends. Now in this class, intermediate second year Maths 2A probability, one pending chapter topic is there, Bayes theorem. Actually after part 1, we have to read this part 2. So in part 1, we have learned what is probability and some important two long questions also completed. But state and prove additional theorem on probability, state and prove multiplication theorem on probability, and conditional probability definition also we have learned, I think so. So now in this class, the very most important theorem, compulsory we can expect the question about state and prove Bayes theorem, and we have 7 marks questions also based on this Bayes theorem. So very important topic, don't miss this topic. So what is statement of this Bayes theorem? First statement we should by heart. Okay, what is the statement means? First I am going to write statement of Bayes theorem. Statement is, note down, suppose capital E1 comma capital E2 comma capital E3 comma so and so capital En. So how many are there? 1, 2, 3, 4, so and so n are there. Okay, En are n mutually exclusive. Please write down exclusive and exhaustive events of a random experiment Okay, very simply I will tell you. First write down statement also we have to read. So for the statement 2 marks will be awarded, for the remaining theorem remaining 7 marks will be awarded. Okay, sometimes they can ask in the question directly, they can give the statement and they can ask the proof. Okay, so whatever we have to know what is statement and what is proof. What is statement? Suppose E1 comma E2 comma dash dash En are n mutually exclusive and exhaustive events of a random experiment with probability of EI not equal 0. What is I means? With I equal 1, 2, 3 dash 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 n, then any event capital A, of the random experiment P of A not equal to 0, then probability of Ek by A is equal probability of Ek into probability of A by Ek by summation I equal to 1 to n probability of Ei into probability of A by Ei, where k value is 1 comma 2 comma 3 comma dash dash n. So this is the statement of Bayes theorem. So we must by heart this statement. Okay, so now proof. So how to solve this proof? First write the given information. What is the given information? E1, E2, En dash dash are mutually exclusive events. Exclusive events means what? Okay, suppose two events A and B are exclusive events. That means there is no intersection part. That is nothing but exclusive events. There is no intersection part means, so A intersection B value is empty. Means A intersection B is empty. So then A and B are called exclusive events. Okay, so like that. First write down, given that E1 comma E2 comma dash dash En are mutually exclusive and exhaustive events. That means E1, suppose if you take only two events, you can write E1 intersection E2 is equal to empty. But here there are n events. So I am writing some EI intersection some EJ is not equal, is equal to empty. Okay, that means what? E1, E2, E3, E4, E5, E6, E7. Okay, so all events are E1, E2, E3, so and so En. All are mutually exclusive, means there is no common between any two events. Next, what is mean by exhaustive events? What is mean by exhaustive? Exhaustive means the union of all events is nothing but sample space capital S. Union of all events, sample space. That means E1 union, E2 union, E3 union, dash 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 union, En is equal sample space. So this can be written in simply union I equal to 1 to n, Ei is equal S. Okay. So according to E1, E2, En mutually exclusive definition, we can write Ei intersection EZ is equal to empty. Okay. Here I value, J value separate, means if you take E1, it not E1, it is maybe E2 or E3 or some anything like that. Okay. According to mutually exclusive events, we can write Ei intersection is EJ is equal empty. Okay. First, Baye had the definition, and from the definition take the first statement E1, E2, E3, En are mutually exclusive. From that we can write Ei intersection EZ is equal to empty, one statement. And from the second mutually exhaustive events means E1 union, E2 union, dash dash En equal to sample space capital S. So this simply in short way we can write union of I equal 1 to n, Ei equal to capital S. Okay. Yes. Next, any event capital A of the random experiment. So I am introducing A also, and given that or let capital A is any event of sample space S. Any event of sample space S means A is equal to, A is some subset of S. Subset of S means A is some event of S. Whenever A is subset S, what about A intersection S? That is nothing but A. Because of if A is subset to capital S, the intersection of those two events is smallest event. That means, for example, A equal to 1 comma 2, A equal 1 comma 2, S is 1 comma 2 comma 3 comma 4, like that. Okay, A is subset to capital S, for example. Then what about intersection of A and S? Again we are getting 1 2, means again we are getting A. So intersection of two sets means which is the smallest subset one, that is the answer. So A can be written as A intersection S. Okay, from this after this step we can write A equal to A intersection S. Then A equal A intersection S means what? So here it is taken as equation 1. S means what? Union I equal 1 to n Ei. So S means union I equal 1 to n capital Ei. So union I am taking outside. So union of I equal to 1 to n A intersection Ei. So A equal. Next I am going to applying probability on both sides. So then probability of A is equal. So when you apply the probability of union of sets, it becomes a summation. Okay. So summation I equal to 1 to n, the probability of A intersection Ei. Okay. Almost all equation number 2. 50%. So each and every information is gathered. Almost all 50% in answer we have completed with these few steps. Okay friends, first statement write down E1 Ei intersection is equal to empty. Next statement exhaustive means union of all events is capital S. After that I introduced capital A is any subset of S, then A subset S, then A intersection S means yes A. So next A means A, intersection means intersection, S means from equation 1 union of I equal 1 to n ei. So continue, take the probability on both sides. Next what? So complete, every information is completed. Next I am going to take left hand side of the given proof. We have to prove this one, P of ek by a equal to some so and so. So I am going to take left hand side and then I will prove. Okay, can I remove this? I have no space, that's why I am going to remove. Did you write this? Okay, please take a screenshot and write down. Okay, next taking, after this I am going to take left hand side P of ek by a. I am going to take LHS probability of ek by a is equal what? I am going to take. Do you remember what is conditional probability? Conditional probability. Don't worry, in part 1 I told you, even you do not idea, I will tell you. Okay. Conditional theorem, just I am repeating. Conditional theorem says that probability of a by b is equal to probability of a intersection b by probability of b. Or we can write probability of b by a is equal probability of b intersection a, or you can write a intersection b by probability of a. Whatever is in the denominator, that will be in the probability of denominator, and in the numerator probability of intersection of two events. So to remember roughly. So here how can we apply conditional probability of this problem? Yes, probability of a intersection ek, probability of a intersection ek by probability of a. So according to conditional theory. So in bracket, since, by using conditional probability, right? So no need to write these steps. For for understanding I told you that one. Just write since by conditional probability. Next is equal probability of a intersection ak as it is write down. But P of a means what? From equation to P of a means, yes, very good, write down. Tell me, summation I equal to 1 to n probability of a intersection ei. Okay. Next is equal, what is the next step? Okay, with the next step we can complete the answer, but how to complete the answer? P of a into a intersection ek means what we can write? Okay, so now we should remember the multiplication theorem. What is multiplication probability theorem? What is multiplication probability theorem? So very simple, from these two conditional probabilities, P of a intersection b equal to P of, if you bring left side, P of b into P of a by b, and from here P of a intersection b equal to P of a into P of b by a. So multiplication theorem is says that P of a intersection b equal to P of a into P of b by a, and which is equal to P of b into P of a by b. If you completed part 1, if you know what is conditional probability, what is multiplication probability, so these are very simply you can get the idea. So using this P of a intersection b equal P of a into P of b by a we can write, or otherwise we can write P of b into P of a by b also we can write. So what we can write here, P of a intersection ek equal, I am going to write P of some ek, with ek I am writing P of ek into P of a by ek, P of a by ek. Okay. Next, in the denominator, summation as it is write down I equal to 1. So here also P of ei into P of a by ei. So completed. Once check your what we have to prove in the statement. Is this only proof? Okay, this only we have to prove? Yes. So for k equal to 1, 2, 3, so and so. Here also k equal 1, 2, 3. Okay, ek means in the left side. Okay, this is the answer. Is it clear? So this is the rough one. No need to write in the answer sheet. Okay. Here by multiplication theorem, multiplication probability statement or theorem. Is it clear? First, write down given information E1, En are mutually exclusive and exhaustive. That means Ei intersection Ez is equal to empty, and union of E1, E2, union equal to S. According to this, simply we can write this. Now take the capital A event, that is any event of capital S, means A is subset to S. That means A equal to A intersection S we can write, and A means A only, intersection means intersection only. S means from equation 1 union I equal to 1 to n EI, then union right outside, then A intersection AI we can write, and next probability apply on both sides. Whenever you apply probability, it becomes P of A, and union becomes summation, then probability of A intersection AI can be written. So taken as equation 2. After gathering the 1, 2, 3, 4 statements, take left hand side of the proof and express the left hand side according to conditional theorem, that is A intersection EK by probability of A. Next P of A intersection EK write as it is. Next P of A means from equation 2. From equation 2, what is P of A? Is nothing but summation I equal 1 to n P of A intersection EI. Then after applying multiplication theorem, what is multiplication theorem says that this is the multiplication theorem. According to multiplication theorem, P of A intersection EK can be written as P of EK into P of A by EK, and in the denominator also written in the same using multiplication theorem. So this is the base theorem, so very important theorem. Let us see one 7 marks question. Actually we have 3 or 4 7 marks questions are there. So first one 7 marks question, see how it is easy, you can learn, you can know. Okay friends, let I am taking the question. So this is also important question. So I told you we can expect theorem or the questions based on theorem. So very important. Fourth one, 3 boxes numbered 1, 2, 3 contains the balls as shown. Box 1, box 2, box 3. In box 1, 1 white ball, 2 black ball, 3 red balls. In box 2, 2 white ball, 1 black ball, 1 red ball. In box 3, 4 white ball, 5 black ball, 3 red balls. Okay? One box is randomly selected. One box is randomly selected, and a ball is drawn from it. A ball is drawn from it. If the ball is red, then find the probability that it is from box 2. So which ball? Red ball. What is box? B2. Okay, box B2. So this is the question. One box is randomly selected, from it the ball is red, find the probability that it is from box 2. So okay, first leave the question. What is the given box? Very simple. First write the given box as still in the answer sheet. Okay, I am removing question. So here how many boxes are there? 3 boxes are there. How many boxes are there? 3 boxes are there. So I am removing the question. I don't get space to solve the problem, that's why. And okay, solution. So in the solution, first to draw the box as it is. Okay, so this is the box. This is the question. So I am just extending total number of balls. So here 1 plus 2, 3 plus 3, 6 balls. From box 2 plus 1, 3 plus 1, 4 balls. From box 3, 4 plus 5, 9 plus 3, 12 balls totally. First box item. Next, about how many boxes are there? 3 boxes are there. So each box I am taking event E1, and box 2 I am considered event E2, and box 3 I am considered event E3. So let 3 boxes 1, 2, 3 considered as event E1 and E2 and E3. Okay, there are only 3 events. Then probability of event, totally there are 3 events, so by 3. Probability of E1 means only one, first box is only 1 is there. Next, probability of E2 can be written as, here also total 3 boxes. Out of 3 events, E2 is one of the event. So like that. Next, probability of E3 can be written as, here also out of 3 E3 is one of the event. So probability of box 3 can be written as 1 by 3. Probability of box B1 Box 1 means probability of E1 is 1 by 3, probability of E2 is 1 by 3, probability of E3 is 1 by 3. Okay, completed. Next information is about the question. Now see the question. What we have to find? Probability of, if the ball is red, then find the probability of from box 2. So how to solve this one? See, from box B1, chosen box B1, chosen box 1, that means E1, box E1. Which ball? Probability of drawing red ball is probability of box E1 ball is red. So E1 by R, E1 by R. Sorry, R by E1. Okay, R by E1. So you just careful here, so don't get confusion. So conditional probability says that it is depending event, it is independent. So red ball taken from box B1, so R by E1. In this box E1, in this box 1, how many total balls are there? 6 are there. In this 6, how many red balls are there? 3 are there. So 3 by 6. That means 3 1 ja, 3 2 ja, 1 by 2. Similarly, chosen box 2, that means event 2. So probability of draw red ball, probability of red ball is, how can we write? Probability of R by E2. That is, in box 2, how many balls are there? 4 are there. And in box 2, how many red balls are there? 1 is there. So probability of R by E2 is 1 by 4. Okay, is there any cancellation? Nothing. Similarly, chosen box 3. Box 3 means event 3. So probability of drawing red ball is probability of R by E3. Okay, you must write each and every step, that will show good appearance. Is equal, in E3 means box 3, how many balls are there? 12 balls are there. And how many red balls are there? 3 there. So do you know probability definition? Number of favorable outcomes by total number of possible outcomes. Okay, 3 1 ja, 3 4 ja, 1 by 4. So each and every information is gathered. Now what we have to find means the probability of red ball from box 2. So therefore red ball, chosen red ball from box, chosen red ball, probability of box, probability from box 2, chosen red ball, probability from box 2 means probability of E2 by R we have to find. What is probability of E2 by R? So now applying Bayes theorem. What is Bayes theorem? Says that probability of EK by A is equal, okay, probability of EK by A is equal probability of EK into probability of A by EK by summation I equal to 1 to n probability of EI into probability of A by EI. This is the Bayes theorem. Okay, we must learn Bayes theorem. So using that Bayes theorem, we can write here what we have to find? E2 by R we have to find, E2 by R. So EK means E2, probability of E2 into P of A by EK. In place of A there is a R, so R by E2 by summation 1 to n means here how many events are there? 1 2 3 are there, so 3 write down. Okay, so can I remove this question? I'm not getting sufficient space. Okay, good. So now from here onwards I will explain. Again, first I am writing Bayes theorem. Bayes theorem, P of AK by A is equal probability of ek into probability of a by ek, okay, by summation I equal to 1 to n probability of ei into probability of a by eia. I just written Bayes theorem. So using Bayes theorem, I'm going to find the probability of E2 by R. E2 by R. Okay, according to this we can write probability of Ek means E2 into probability of A by E2. Okay, by summation I equal to 1 to n probability of Ei into, okay, here only I can expand because of summation means sum of the terms. Here only 3 events are there. So one is P of E1 into P of A by E1. A means R by E1. Next plus probability of E2 into probability of R by E2. Next plus probability of E3 into probability of R by E3. Okay, 3 events are there. So now substitute what is probability of E2. What is probability of E2? 1 by 3. And the probability of A by E2. A by E2. So A means what here? A nothing but R. R by E2. R by E2 is 1 by 4. 1 by 4. Next probability of E1 is 1 by 3. Next probability of R by E1. R by E1 is 1 by 2. Plus probability of E2. Probability of E2 is 1 by 3. Probability of R by E2. R by E2 is 1 by 4. Plus probability of E3 means 1 by 3. Probability of R by E3 means 1 by 4. So which is equal, see, we have to simplify this, then we can get the answer. That's it. In numerator 1 by 3 into 1 by 4, keep as it is. In denominator 1 by 3, 1 by 3, 1 by 3 is common. I am taking 1 by 3 common. Then the remaining terms 1 by 2 plus 1 by 4 plus 1 by 4. So 1 by 3 gets cancelled. Then 1 by 4 by, in the denominator 2, 4, 4. 4 is the LCM. In 2 table 2 times it goes. 2 1 are 2 plus 4 is the same, 1 plus 1. So 1 by 4 by 2 plus 1, 3 plus 1, 4 by 4. So 4 4 cancel, 1 by 4 is the remaining. So probability of E2 by R, E2 by R is 1 by 4. So this is the answer. Okay, very simple. First write the box as it is lead, and 3 boxes they mentioned. So probability of box 1, probability of box 2, probability of box 3, each 1 by 3, 1 by 3, 1 by 3. Because of there are only 3 boxes, so by 3, by 3, by 3. That's it. Next, choose in box B1. What is the red ball probability is 3 by 6. 3 by 6. Next, choose in box 2. What is the probability of red ball is 1 by 4. 1 by 4. Because of red ball 1, total number of balls 4. Next, box 3 choose in, probability of red is 3 by 12. 3 by 12. 3 by 12 means 1 by 4. Okay. How to write this one is important. Next, what is question? Question is choose in red ball from box 2. So that means red ball from box 2 means E2 by R. So E2 by R means what? So this is can be expressed according to Bayes theorem. So to find this one, before this step, you just write the Bayes theorem statement and expand that, you will get the answer. Okay. So by using Bayes theorem, taken from Bayes theorem. Okay friends. Okay friends, next in the next part we will learn the remaining 7 marks questions are there. Similar questions are there with giving some different situations, how to use Bayes theorem, how to solve. Thank you for watching our classes, and please subscribe if you are newly watching. In the next video we can meet. Thank you. Bye bye.